Hi, I'm Francesc Campoy, and this is Just for Funk. So welcome to episode number 8 of Just for Funk and part 3 of Flappy Gopher. Today I am back to San Francisco, a beautiful studio here in the San Francisco office of Google. So today we're going to finish Flappy Bird. And if you have not seen them, there's 2 episodes that you should check them out first before understanding what we're doing here. The first episode was 2 episodes ago, and it was the beginning of Flappy Bird. Basically how to handle the basic UI things, how to create a window, how to display images on it, etc. On the second one, what we did was to start animating things a little bit more and handling events. Handling events also required to be able to lock a Go routine to a thread. So if you've never seen that, I definitely recommend checking that episode out. And today we're going to be handling collisions. And to handle collisions among different events different elements that are moving around and being updated by different Go routines, we're going to be probably needing some mutexes, and I think I'm going to be using a channel. Not completely sure yet, but I feel like it's a nice solution for something I want to build. I think it's going to be lots of fun, and probably the last episode of Just Funk. Probably the last episode of Flappy Bird, Just for Funk's going to keep on going until I get tired, I guess, or something else, who knows. Okay, so let's start by seeing how far we got last time. Going to be using go build-i because someone suggested it. It will do incremental builds, which means that for our case, since we're using Seago, it will be much faster. So actually, there you go, much faster. So let's run it. Flappy Gopher. We should be able to see that the bird just bounces there. It works. We can jump and stuff, but that's pretty much it. What I want to do first is I want the game to restart whenever the bird touches the ground. So we're going to detect when that happens. We're going to show the text again rather than Flappy Gopher. We're going to show game over, and then we're going to continue with the game. So we already detect, actually, in the paint function here, whenever the bird is about to die. So what I'm going to do first is I'm actually going to split this paint function into 2 pieces, because these actually not only paint, these basically update. So there's an update that does not fail and does not get any of the values, and then we paint. So when we update, what we're doing is we incremented the time, we're updating the speed, and then we check if the speed is, so if the position is 0, and if it is, we bounce. So what we're going to do now is actually, instead of doing this, we're going to do b.dead equals true. And we're going to need to have a dead boolean. That way, we'll be able, from the scene.go function, we'll be able to check. So after painting the scene, which actually we're going to also have update. So this is going to call s.bird.update. That is going to be paint. So that's going to be the pure painting of things. This is going to be more like the part where we update the whole scene before we continue. And we're going to say, okay, so an update, when we're calling it here, s.update, then painted, and if painting fails, we do something about it. What we're going to do also is we're going to say, if after updating, if the bird is dead, and I'm going to define it as a method, we'll see in a minute why. I'm going to draw title. So I'm going to draw the title. Instead of Flappy Gopher, I'm going to say game over. So draw title was already defined before, but it did not have any text coming from it. So we're going to add that text. Before it used to do only Flappy Gopher. Now we'll do text, which means that we can come here, draw title, and say Flappy Gopher. Okay, so we're going to draw the title and sleep for a second. And then we continue. Bird is dead. Why do we do is dead instead of just accessing the boolean? Well, there's a very good reason for it, which is all of this is dangerously close to a data erase. And rather than having data erases, I'd rather have contention in mutexes. So what I'm going to do is I'm going to add a mutex here. If we had a lot of contention, I would consider doing sync.rw mutex. Actually, let's do it. Why not? So this means that only that we can have many people, many Go routines trying to read from the bird at the same time, but only one writing. Or actually, if one of them is writing, no one else can access it. Update will change the value. So we're going to do b.mu.lock and defer b.mu.unlock. But paint, for instance, will not change the value of anything. So we can do rlock and runlock, which are the equivalent for read only, right? We're not changing anything there. We're sure. Yeah, we're not changing anything. Destroy goes over the textures. It actually calls destroy. So let's say that no one else can access it at the same time. And jump also changes the speed of the bird. So we should also change this with lock and unlock, not rlock and runlock. New bird doesn't need that at all. So that's pretty good. Now this is pretty safe. It feels safe to me. So let's build it and run it. Oh, we did not define the isDead method, so let's do that first. So isDead returns a Boolean, and this is going to be b.mute.lock, rlock, defer b.mute.runlock, and return b.dead. And we could consider actually protecting this by moving to a different package and then making that dead boolean non-exported and only the isDead method exported. But I feel like right now at this point is a little bit overkill. Just having a different files and making sure that you don't access weird things should be enough. But if this was something, if this was a project that I was working on with other people, I'd definitely do that. Just in case, avoiding problems for later on. So if we do go build, game over, well, that's not good. What's going on? Okay, so that's actually expected, or at least I expected it, because once we are done, we need to do something about it. We need to reset the game. So we need to do s.reset. And reset is not, or let's call it restart. So we're going to restart the game from scratch. So restart is not defined yet. So as scene restart, it's going to call restart in every single one of the things. So far, there's only one bird. So we're going to call restart on the bird. And bird has a, let's put it here, restart. Restart's going to change things, so we need to lock it. And what we're going to do is we're going to do b dot, the position of the bird is going to go back to the middle. So we started with 300. Let's do it 300 again. The speed should go back to 0. So basically, we're starting again from the top and falling at 0 speed at the beginning. Cool. Let's try it now. Whoops. That was too fast for me. Oh, I did not fix it. What is going on? Let's see. Oh, so one of the things that we need to do is also say that the bird now is not dead. Bird is now not dead. Otherwise, it will be dead forever. Okay, so the bird is alive, it dies, and we start again. Great, so the next step is to add pipes. And I'm gonna start by having only one single pipe. I'm gonna add to the scene, where is this? We're gonna say that we have pipe is the pipe, so we have only one pipe. This is pretty simple. I'm gonna create a new file to hold all the pipes. It's gonna call it pipes.go, and the package is main, and the type pipe is gonna be a struct. And okay, so what do we need to do? What do we need to know about a pipe? There's actually not that many things. We need to know what is the position. Pipes are going to be moving left rather than the bird moving right. A little bit of a trick, but I think it's going to make our code easier. So pipes are going to be moving left, which means that we need to keep track of x. And int32 is the bytes that we're using. On SDL2, the position is int32, so it's just easier to do it this way. Then we also need the height, and the height's going to be also an int32. And what else do we need? So we need the position, we need the height, we need the speed. We could say that all the pipes move at the same speed. So let's actually say that we put it there. So the speed's going to be constant. We put it also as int32. Oh, and also we need to know if a pipe is upside down or from the bottom up. So we're going to call that inverted pull. So if it is inverted, it means that it's coming from the top down. If it's not, it's bottom up. And also we need the width, width as in int32. Now what I'm going to do, and this is when it starts to get interesting in my opinion, is our update is going to call s.pipe.update. And restart is going to call s.pipe.restart. And paint is going to call basically the same, but s.pipe.paint. And this is going to call s.pipe.destroy. So now we have these methods, right? Update, restart, paint, and destroy. And these are the ones that we're going to be repeating over every single one of the elements we have in our game. So you could imagine that we could define quite easily an interface that is exactly this. So we could put everything together and make our code a little bit simpler. In this case, we don't have enough different kinds of elements to justify that, so I will not do it. But if you had something where all of a sudden you have, let's say, more things flying around, or I don't know, whatever you feel like having, it is a good idea to start trying to find out all of those common behaviors that justify having an abstract representation of that behavior, which is what we call in Go an interface. So we're going to define. Let's try to do this like a pro. And actually, we're going to need also a new pipe function. And that new pipe function should return a pipe. Let's say that the position is going to be 400, which is right in the middle of the screen. H is going to be 300, which is right up to the middle of the screen. The width is going to be, let's say, 50. Speed is going to be 1. I have no idea about this yet. So, and let's say it will not be inverted. So when we create the scene, in new scene, we're going to say that p.err, it's new pipe. Oh, we need to pass the renderer because we're gonna be loading the textures linked to the pipe. We're gonna need to do that too. So if the error is not nil, we're gonna return that error. Okay, so new pipe is gonna be getting a render, and it's gonna be using that render to load an image. Let's see how we're loading the background. This is pretty much the same thing as we're gonna be doing here. But right on background, it's going to be pipe.png. Could not load pipe image. That's going to be returning an error, obviously. Loads texture. Oh, we need to add this import statement here. And we need to keep track of that. So texture is an SDL texture. So texture is a texture. And inverted false. What is the problem with this? Nil. Yeah. So we return a pipe and no error. Okay, so now we have a pipe, and that pipe is right in the middle. So how do we paint that pipe? So what we need to do is we need to call copy, right? So similar to our paint on the scene where we paint in the background. It's actually not that different to this. But we're gonna need to paint it to specific rectangle. So our p.g is actually gonna be p.texture. So we're gonna painting that into a rectangle. And the rectangle is gonna be, let me copy that from here, from the pipes, from the bird. We're gonna have a pipe that's gonna start at p.x. So that's the position we're gonna have it. And then we're gonna have from p.x forward. The width is gonna be p.w. The height is gonna be p.h. And the starting point will be p600 minus p.h. Because that way we'll have 600 will be from the bottom, so we have 400, it will be somewhere around, 300 will be right to the middle, and it will be 300 height. When we do restart, we could do pipe equals x equals 0. 400. So that will just move the pipe back to the beginning. At some point, we're gonna need mutexes around here, because this might be used from different places. So let's actually add it now. So mutex is a sync.rmutex. So when we created refine, when we paint, we're gonna p.mu.rlock and defer p.mu.runlock. And when we restart, we're gonna need to do lock unlock, and same for update. Update is actually quite simple. On update, everything we're gonna do is we're gonna move the pipe to the left. So we're gonna say that the position is minus the speed. And finally, destroy, it's going to call destroy on the texture. Cool, so we have our new pipe, paint, restart, update, and destroy. And if all of this worked, which, who knows, now we should be able to see how a pipe appears in the middle and it doesn't do anything. Actually, no, sorry, it starts moving slowly to the left. But there's nothing saying that if we touch it, we should die. So that will not happen yet. So let's try to run it. Pipe has no fill or method restart. Hasn't it? Restart. There you go. P declare not used ints in the go. Let's see, where's the line? 29. Oh yeah, pipe is P. And now, cool. So we have that pipe and we can pass through and everything is fine. So probably not what I wanted to do. But hey, it's not that bad. It is actually pretty decent, I say. Okay, so the next step is obviously to make that pipe basically kill the bird if it touches it, right? So what we're gonna do is I'm going to say that when we call scene, when we do update the scene, the bird will receive the pipes. So, or we could even do it s.bird touch the s.pipe. So now what we're saying is the bird will decide if it's touching the pipe or not. If it is touching the pipe, it will do something quite similar to what it did when the position went below 0 and just say, okay, I'm dead, and we'll restart the game. So let's try to do that. I'm gonna add it to the end. So touch a pipe. If so we're gonna be reading only from the bird. So we're going to do rlock and runlock. And also we're gonna be reading only from the pipe. So we should do p.mu.log, p.mu.unlock. Now we know that both the pipe and the bird are protected for read-only access, which is good enough for us because we're just checking if they intersect. Okay, so how do we do this? I'm gonna check first if the pipe is too far, if it's too far apart on the horizontal axis. So that is if the position of x, which is where the pipe starts, is bigger than the position of the bird, which we don't state anywhere. it's this position here. You know what? Let's actually make these fields. So we're gonna have on the bird, we're gonna have x, which is an int32. Actually, let's have x and y be int32s. For the speed, it makes sense to have a float because we want that smoothness on the acceleration. But for the position, it's pointless, so we don't need that. Okay, so we have the position and then the width and the height too. Okay, so that is not compiling because probably I have, okay. So what we're gonna do is b.speed, that's gonna be int32. And now when we create a new bird, x is gonna be 10, w is gonna be 50, and height's gonna be, what did we say, 43. Okay, so now that will be, we can get rid of this one, which is pretty nice. This will be b.height. There's no point in having those parentheses there. b.w and b.height. Okay, this doesn't change anything. I'm just making it variable, so then we don't need to repeat those constants all over. So here now I can say if the position of the pipe is bigger than the position of the bird plus the width of the bird, then we're not touching anything, we're good. Same way, if the position plus the width of the pipe is less than the position of the bird, then it means that it's not touching either because it's already passed. So too far right, too far left. If we are higher than the pipe itself, also we're safe. So if the position of, so the y position of the, no, there's no such a thing. So if p.h, the height of the pipe, is lower than the position of the bird minus b.height divided by 2. So basically, when we paint the bird, we're actually painting it half of the bird up, half of the bird down. So we want to take that piece into account. That's why we have that b.h divided by 2. So that is the pipe is too low. So if the pipe is too low, we also avoid it. Otherwise, we are dead. So b. Oh, interesting. Okay, so we need to lock the bird for locking, for writing, because we might change it. b.dead equals true. Cool. So this might work. I will not say this will work. This might work. Let's try it. Okay, so we have our bird. This looks pretty good. We can avoid it. I think if I fell on it. Okay. So we can pass it over. That's good. I feel like the gravity is a little bit too much. It's making it hard for me to play. So let's move it way lower. So now the bird's bouncing. Yeah. Okay, so we can pass it over, and that works. We can go onto it, and we die. We can try to land on it. That was not landing on it. And it also dies. Cool. So we could say that the game now is working, but what happens if the pipe happens to be inverted? We have not written any code for that, so that's not going to be working. So we're going to be able to go here, and that is not even painting it on the... Yeah, okay, so it works because we're not using it at all. So there's a bunch of problems here. Let's start by painting it where it should be. This should actually be painted from the top down. So what we want to do is, so if the pipe is inverted, the position will start at 0. The height will be the same. The width and the other positions will be the same. But what we want to do is we want to also invert the texture, right? Because otherwise, let's see how that looks. You see that that pipe has the end on the top, which doesn't really look like I want it to. So what we need to do is there's actually an extra method, an extra function. No, it's a method on renderer. Rather than using r.copy, we're going to use r.copyx. So if we go to the documentation, so we get that import path, and we do godoc.org/that. We have a copy x, that method there, that receives a bunch of things. Angle, so angle will be 0. We don't want to, I mean, we could do rotation of 180 degrees, so we would also turn it around. But we also have a flip there that looks pretty good. And we have flip none, flip horizontal, flip vertical. So I should be able to do, okay, so the texture is the same. The rectangle for source and destination is the same. Then the angle is going to be 0. The center should be 0 maybe. So if the center is nil, then rotation will be done around, well, there's no rotation, so it doesn't really matter. So just going to pass 0 degrees for the rotation, nil here. And then we're going to pass flip. And flip is going to be SDL flip none. But here we're going to say flip equals SDL flip vertical. And we're going to call this function instead of that one. OK, so now what we've done is whenever the pipe is inverted, we flip the texture. Let's see that. Cool. So we can pass it below. Wait, I'm really bad at this game. And we die. Why did we die? Well, because the collision is not taking into account if the pipe is inverted or not. So we need to fix that. Where do we do that? So that is actually bird. This is an interesting question because I start to add a lot of logic here in bird that corresponds to pipe. I'm going to keep it like this for now, but I'm not super happy about it. OK, so if the pipe is, if pipe is inverted, and that is the case, the pipe is too low and it's inverted, then we're good. But then we also need, if the pipe is not inverted and the height is higher than, let's think about this. The height is, so 600 minus the height is less than the position plus the height, return. So that should be pipe is too high. So now what we're doing here is 600 minus pH. We don't need those parentheses. 600 minus pH is how low the pipe gets to, right? If it's 0, it gets up to 600, but if it's up to 300, for instance, we'll get down to 300, or 400, we'll get down to 200. So if that is lower than the position of the bird, including the top half of it, then we're colliding, and we should plus greater than. So if that is greater, let me think about this. So if that is greater, then the pipe is too high, and then inverted pipe is too high, and then we're good too. Okay, let's try it. So for inverted pipe, we should be able to pass through. No! Okay, we're not able to pass through this. Let's think about this. So if the pipe is not inverted, oh, if the pipe is not inverted, then we do that. If the pipe is inverted, more than. To make sure that this is actually working, let's change the pipe, the random pipe, which is not random at all, but whatever, to be 100. So I want to make sure that it's not, we just didn't get it right just out of luck. So we should be able to pass somewhere very close and be fine. But if we pass closer, we should die. There you go. Cool. Okay, we have one pipe that is inverted or not, and if we touch it, we die. The pipe moves quite slowly, but we can play that with the number here, so that is pretty good. You can imagine that that speed level is actually the level, the complicatedness, the difficulty of the level. So the higher it goes, the faster it gets. You could also play with how tall pipes are, stuff like that. You could play quite easily with those. What we're gonna do next is we're gonna have more than one pipe. So let's do that now. In pipes.go, I'm gonna create my new type pipes, which is a struct. I'm gonna move the texture there. What else? I'm gonna move the speed, because all the pipes are moving at the same speed. But they don't need to. Actually, that'd be a cool thing to do. Like some of the pipes move faster. That would feel really weird. But you could totally do it. Actually, now let's move it there. I'm gonna put it here. So all pipes move the same speed. All pipes use the same texture. All pipes have the same width. Not necessarily. So let's leave it at that. And the position, the height, and if they're inverted or not, that changes per pipe. So we're gonna do it this way. And then we have the pipe, which is a slice of pointers to pipe. And I'm doing a pointer to pipe rather than pipe, because that way, if I iterate over all of them using range, and I call a method that modifies the pipe, if I didn't have the pointer here, we could try to modify on a copy of the pipe rather than the pipe itself. So it would not work. That's why I'm using slice of pointers to pipe. We're gonna provide a new pipes. And that's going to be actually very similar to this one. So let me copy and start modifying. So new pipes will return a pointer to pipes. It's going to load the texture, and it's going to set the speed. And there's not going to be any pipe in there just yet. Pipes, oh, speed. Speed is, let's say 2, a little bit faster. Cool. So now we have, and pipes is going to be nil. So now we have a list of pipes. Then we're going to need to define those same methods that we had before. So all the methods that we had, paint, update, and all that stuff, we're going to define the same. But we're going to define them on pipes. So when we call paint, what we're going to do is we're going to, oh, interesting. We're going to need also a mutex here, because we want to keep the list of how many pipes we have protected, right? So I'm going to do mutex everywhere. But that way, I think it's better, because every single object in the game is able to keep track of its own state with the mutex, which makes everything much easier. This is why mutexes were invented, basically. We're going to paint. So new pipes will load the pipe. When we paint, we're going to go through all the pipes. So for p.pipes dot let's call it PS. PS. Okay, so for every pipe, I'm going to call ps.paint of the renderer, and I'm going to pass the texture too. So that way we have this, we don't need to do anything else. And if any of these fails, we'll return the error. Otherwise, we'll return the error. p.paint. Okay, what is the problem here? I define ps.pipes. And paint is not, it's defined, but it has one too many methods, one too many arguments. That is fine. Texture is not here now. And speed is not here now. Paint now gets a texture, which is an sdl.texture. And we use that texture here. Okay. Then, so that is paint. Restart is going to, so pipes, ps, it's going to simply drop all the pipes. So it's gonna say that ps.pipes equals nil. So it's gonna remove all the pipes. Which means that we don't need to restart any pipes anymore. So I'm gonna remove this method here. We don't need it anymore. Update for ps pipes is going to be quite similar too. It's gonna do for p range ps.pipes p.update. So basically just call update on every single one of them. And then destroy, it's going to destroy the texture. We should also lock it, as always, which means that we don't need destroy anymore here, because we don't have the texture. This should be okay. p.speed. Oh, you know what? I can't be bothered to do that right now. So I'm gonna move that here. Okay, so here we can lock the mutex. Basically, this is the list, right? So we're locking the list as read. We're only reading that list, but we're modifying the pipe. So we're gonna do p.me.lock, p.me.unlock. And the speed is stored in pipes, not in pipe anymore. So that's why I was complaining about it. We changed the code a little bit, nothing really crazy, but basically now we have pipes that contains a bunch of pipes, and then every pipe has its own information. If I run this, nothing interesting should happen. So go build. Well, other than it doesn't compile, that is interesting somehow. Oh yeah, we need to modify the scene.go. So scene now has pipes. Pipe dot, so as the pipes.update, as the pipes.restart, as the pipes.paint, as the pipes.destroy. That's the nice thing about it. Now we have all the methods all the time the same. So it's dot. Ooh, okay. So that is an interesting one. So I'm gonna change that and say s.pipes.touch s.bird. And why I'm doing this is because now when we do func touch a bird, what we're gonna do is we're gonna do something quite similar to this. We're not gonna be modifying the pipes. We're gonna be modifying only the bird. So we're gonna not touch anything here. We're going then to say we're gonna iterate over all the pipes, and then call p.touch of b. So now we need to define on the pipe func p pipe touch the bird. We're not modifying the pipe either, but we're locking it for a read. So we're locking the pipe to be ready to be read, and then the bird now doesn't need to lock that pipe anymore. It doesn't need to know anything about that pipe. It just needs to know how to access stuff, and then just finish. So this looks pretty good now. Okay, but unknown field on type sin. We're still not done. Line 34, pipes equals new pipes equals pipes. Texture declared and not used on line 88. Indeed, new pipe doesn't require that anymore, which means that new pipe doesn't require this anymore, which means that new pipe doesn't require this anymore, which means that new pipe doesn't do much anymore, which is okay. New pipe now just returns some random pipe, which is not random, and we might make it random in a minute. Okay, so Flappy Gopher doesn't do anything. Why? Well, we removed all the pipes. There's no pipes, and we're not adding any, so it is expected not to have any pipes. But let's add them back. And this is where it starts to be kind of cool, in my opinion. So what I'm going to do is, on pipes, when I call new pipes, I'm going to start a new go routine. And that new go routine, what it's going to do is, it's going to sleep forever, loop forever, and then it's going to create a new pipe, add it to the list. So we're going to need a reference to this. So I'm going to move it up here. So our pipes is there. It's going to first lock, then ps.pipes. It's going to append a new pipe to the list, then unlock, and then sleep for a second, and return ps. Okay, so basically what we did is simply add one more function that every second is going to add one more pipe. So let's see if that works. Should be able to see it. Okay. So it's adding the pipes at the beginning there, which is not exactly what we want, but that is something. So our new pipe is going to need to start them at the end of the screen. The height should be random. So let's say that the height is going to be something between 100 and what could we say, 400, which means that at 300, so at most it will be 2/3 of the screen, which is already kind of hard. That's going to be an int32. The width, let's say it's going to be 50 all the time. And the inverted, let's do it with a float 32 and say it's over 0.5. Float 32 returns a number between 0 and 1, which means that 0.5 means that 50% of the pipes will be inverted. Okay, let's run it again. Whoa, that was bad. Okay, I can do this. Cool. Look at that. No. That starts to be a fun game now. That is, I like this. Cool. So now we have pipes that appear and start going that way. The problem is that whenever a pipe is gone, well, we just keep on adding more and more. So we never delete that pipe. So what we could do is we could say, so when we update pipes, we're going to need to lock and unlock. The remaining is a list of pipes, list of pointer to pipes. if p.x is more than 0, then it means that the remaining pipe should still have it. So remain p, and then we're gonna set the pipes to remainder. So basically now we're gonna filter out those that are there that pass the horizon, because they're pointless, and that way we can free some memory. They disappear a little bit soon, so we should do p.w too. Once they're actually completely gone, we should stop it. So let's try it again. Okay, let's see if I'm able to pass at least one of the pipes. Okay, it passed, so now we're good. Cool, so there's many things that we could add to this. Like we could probably add something that keeps track of how long you've been playing. So in that case, it's able to say, oh, you beat the record, like you went over 30 seconds or something like that. So we're gonna need to keep track of those records and everything. And I don't know, I feel like probably Firebase is a good example, a good place where we could use this. That way you don't need a backend. Everything you're gonna do is just create a reference on Firebase and say, hey, my record is 30 seconds, and see who gets to the ranking. There's many other cool things that we could do, but I feel like this is enough for today. So I'm gonna stop here, and I'm actually gonna stop here with the whole game. No more Flappy Gopher. I'm so sorry, no more Flappy Birds for you. But I will open source all of this code, make it available to all of you. So if you have any questions or if there's any bug, you'll be able to file issues on it. And if by any chance you actually find a bug, please let me know, because I will make another video, even if it's a short one, explaining what is the bug and how to fix it. I hope you enjoyed this last episode of the Flappy Bird trilogy. It is not the last episode of the series, so do not worry. As always, thanks for watching, and see you on April 1st.